Hello YouTube viewers, welcome to my channel Science to Technology. Anupam Vipul here. Today I'm going to welcome you to my show Camera Tuesday, and today we're going to talk about high speed camera. So let's dive right into it. Now, high speed camera simply means high speed recording because the playback of that recording would be fast. Slow, as in this is the conflicting part about it. Is like you say it's a high speed, but it gives you slow motion. That's the primary reason for that. Your recording is in a high speed, but your playback is in slow motion. So how the heck we guys accomplish this magic? It's very simple. You take a second, you stretch it into 30 parts. That's your normal camera. Let's say 30 frame per second. You stretch it to double, you get 60 frame per second. Now take a high speed camera. That's like ta-da! That stretches to bare minimum to classify as modern days high speed camera. It must stretch it to upwards of around 1000 frame per second. Now the reason why we have that modern barrier is simply because our eye has the ability to see things moving very fast. Now you might be say then how can we see smooth movie at 24 frame per second? Is that our heart rate is not pumping at that point, especially, and our eyes are not camera. They do not take snapshots like they are not taking snapshots. They are a scanner, so they scan. So if our eyes are just chilling, bit zoomed out and starting to see the whole picture, you don't need very high frame rate. That's why movies can be excited. But when you see focusing on every little dot and when your eyes are moving around, you can easily enjoy the speeds of 120 frame per second. That's why gaming monitors are that fast, and people can easily tell, hey dude, this is 120 frame per second, this is 60 frame per second. So our eyes are a kind of scanner, so this must basically high speed camera must possess the ability to exceed that threshold. That threshold, some people say it's like around 200 frame per second, especially if you are in really dire situation. You can see things happening very slowly, but for every second. So 1000 frame per second, it is like if your camera cannot do 1000 frame per second, people generally will not qualify it as a high speed camera. So that's what we are like. We are taking 1 second, stretching it, capturing at very high speeds, and then showing it you at normal speed. So how does it work? Now this system is a bit different than our normal camera. Now I'm talking about high-speed camera as an industrial equipment. So it is a bit different. Now camera sensors, they may be exactly the same or made by the same manufacturer as Sony, ON semiconductors and things of that nature. But generally all sensors have very high bandwidth coming out of them. You generally never get that simply because again it's getting few gigabytes per second from your mobile sensor. So sensors on this are the same. They have like a very high throughput, but that throughput is not thrown away this time. So you generally take that throughput and you try to utilize it at that speed. This is where your cost starts to pile up. At this point, like the sensor is more or less the same thing, but the moment you want to extract that same speed, you will run electron through it at very high rate. Side effect, you will heat it up. That's why you will see always high speed camera either have a very large heat sink or some scenarios very large heat sink plus a fan. That's the reality of it, because if you try to pull it, basically you are trying to read electron out through it very quickly, you will heat that puppy up. So we have to figure out cooling very seriously. The cooling on these puppies are actually very difficult compared to red cameras. Red cameras are like cool as cucumber for these puppies. So you try to read as fast as you can in the sensor, and that's the limiting factor. Whenever you say somebody is like, okay, this is a 4K camera and it can do 10,000 frames per second, the reason why people are generally tell these things at two different intervals is simply because 4K you will only get like 4,000 frames per second. The moment you start to achieve 10,000 frames per second, the resolution will start to go down. Why? Because there is that pipe is the final limit. That pipe is the main thing. So if your pipe is, let's say, instead of 2 Gbps is like 5 Gbps, awesome. That's the main limiting factor. So all the data is directly sent to a buffer. Now this system only turns on when you quote unquote arm the camera. High speed cameras have a bit of a different recording simply because many times you are trying to record events which may inherently have a delay. Basically, let's say you want to record something when let's say a spark happens. You're like, okay, I will send a high voltage current through this and it will go boom and I'm gonna capture it. Here's the deal. The time you are capturing it, the event has already occurred. So how the heck are you gonna record it? So that is the reason why they generally send the data to the buffer, and that buffer is continuously recording. It's just keeping the buffer recording, and the moment you press the trigger, you rewind it, quote unquote. Basically, you stop the buffer, basically fresh footage coming, and you're like, okay, now send the whole video to the main data. So you take it away from RAM, and almost all high-speed camera generally have a very healthy amount of RAM. They could start as little as like 8 GB and go as ludicrous as like 256 GB. So they have a lot of RAM. And that is the reason why even Chronos exists, because Chronos literally that instead of building custom RAM, they directly stuck a laptop RAM into this. So that buffer does continuous cycling, and then you trigger it. Now trigger is the main thing. At the moment you go into any site which deals with high speed camera and all that, and you will get confused, like instead of normal things like aperture, shutter and all that, they'll all be talking about this trigger, it has this trigger, it has this trigger. That's the main reason, simply because many times you want to figure things out, like, hey, when did I send the, let's say, high speed current, high speed I'm saying this high ampere current, and when did the circuit breaker blew. So you could have that trigger itself, basically the moment you deploy the switch, that itself could trigger the camera, so you can easily see how long it took that for circuit breaker to break the connection. And that is a very critical thing, because I'm specifying this is not a tool as a, like, YOLO tool, it's an industrial equipment. So triggering is a very important, and the moment you trigger something, depending on your memory, depending on settings and all that, they will say like, okay, now I'm gonna dump like last 8 seconds or last 15 seconds. That second is directly proportional on basically how much RAM you have. And that's why, like, you will see phantom cameras having huge memory cards and proprietary BS. And the reason why they need something like this is not because like they want to extract money out of it, that's absolutely clear, but they have a reason for that, simply because a punch, let's say you take a punch and it's like boom, how long would it took? A normal camera have 2 seconds. Here's the deal, if you record at maximum frame rate, let's say around 30,000 frames per second, that will take half an hour. The footage would be half an hour long. So memory is a very serious thing. So to make sure the Chronos was like at a low price, they had the ability to, like, you can just remove the garbage part and just take out the important part. So that's how it works. It's completely different mindset. And so do not get confused by trigger. Everybody is like trigger triggering. So trigger is simply basically you stop the recording at that point. It's like trigger, that means you have stopped the recording, and then now the buffer will dump into the primary memory. So what about this speed? Now I specified that pipeline from the sensor is the main choke point. So you always have to understand this. You can get the speed or you can get the resolution. You will rarely get both of them. So generally, higher the speed you want to get, the lower resolution you're gonna get. I'll give you a simple example of Chronos camera. Now it has this is version 1. It has like 1280 by 1024. Basically it's more or less 720p. Now if you are acceptable with 720p, you can push this puppy to 1500 frames per second. Now that's good. That's like tangibly good high speed camera. Now if you want to go to YOLO speed, basically you want to see gunshots and all that, you need to minimum around 10,000. Now let's say you want to really push it and, like, want to see things in slow motion, you need 20,000 frames per second. The resolution goes to 336 into 190. Size of an icon, literally normal size of a Windows icon is at the same size. It has to do this simply because the pipe that is coming from the sensor is not large. So to make sure that time is captured much more slowly, they have to shrink down the resolution. And you might be saying, okay, I'm talking about Chronos, it's like a small cheap camera. Same will happen with Phantom. Again, the bandwidth would be different, but let's say Phantom may have a sensor that does 10 Gbps, let's say. I doubt it, but let's say they have something that they will be like 4K camera, YOLO, 1500 frames per second or 4000 frames per second. That will be starting, but the moment you start to go higher, the resolution will start to go, because that pipe is the choking point. We have no way of bypassing that. That is the inherent limitation of silicon. Unless you design a better silicon, you cannot go around it. So you will always find this scenario where you can get high speed or low resolution, or you can get slow speed or high resolution. Now it's not a big deal for industrial use, simply because let's say you want to see how let's say circuit breaker works. You're cool with, like, let's say not having the highest resolution, but you want to see 3000 frames per second. It's like how long did that spring took for it to melt and, like, disconnect the system and all that. You need to see this. That's how, like, all the circuit breakers are rated. It's like 5 millisecond response time and all that. You need to see that. And in some scenarios where you are figuring with ballistic things, you do not need too much resolution. You will go like, hey, 6640 by 96, and you can enjoy 21,000 frames per second that time. And many times you can find high speed camera that has black and white for this exact reason. Basically, the most processing step you remove, the smoother the pipeline becomes and more efficient it becomes. And because of removing that Bayer filter, you also get low light sensitivity, because you are slicing time in such a small interval, because the light intensity will drop. So the biggest example of that is simply because the high speed camera that was used for nuclear testing, it was so high speed that a nuclear bomb did not overexpose it. Let that sink in. A nuke went off and it did not overexpose the camera. Actually, it was underexposed simply because, like, you can easily see what was happening inside the system. They did not have to do much because of the time frame was so small, not enough photons came in. So it will always happen. Now this is one aspect. Many times you'll be like, hey, I want 4K at, like, 40,000 frames per second. You don't need that. Tangibly, you do not need that. Like, there are high speed cameras that are used for let's say some rocket launches. crash testings, industrial use, but they are all tailored for that scenario. Let's say you want to make a movie, let's say Sherlock, and you are going YOLO on slow motion and all that. You're gonna take a Phantom 4K. Why? Because you need the resolution, but you do not need the slow motion. You're not gonna crank it down to, let's say, 20,000 frames per second, because that will, a person running would be like, 2 hour long, not even two, like 5-6 hour long it will become. So you always have to pick your battle. Many times people will say, even if they have a 4K camera, they will like, hey, only record at full HD. Why? Because of the frames you're getting quote unquote so many frames, you can scale it up quite well without too much stretching. So you can literally do full HD, but get really buttery smooth scenarios. So there is always a need to that. And let's say you have a processing plant where you have bottling of water and you need to check a serial number in each bottle. How the heck are you going to do that? Ta-da! High-speed camera. These are the primary consumers of high-speed camera, industrial use. So what are your options? Let's say you want to get into this. What are your options? Well, this time it's kind of simple in one way, simply because the competition in this market is not that much, and the reality right now is very simple: more money equals better equipment. Because it's treated as an industrial equipment, and sometimes it's directly put into insurance schemes, and it's like an industrial equipment. Basically, if this system malfunctions, your whole production line could go down. They are a completely different beast. So generally, more money gives you a very better basically equipment. Now Phantom cameras they started as the same high speed camera for industry, but they started to slowly go into the cinematic aspect, and you must have seen the first foray, not even first as in, but like very popular foray, Mythbusters. They utilized these cameras like nobody's business, and they became very popular, and they slowly started to become more and more, because industry does not want 4K camera. They are like, dude, at full HD I can read the serial number, I'm okay with that, and give higher frame rate, but again, like I would need a better computer to handle that throughput. They're like, dude, this is enough. Yeah, give us more power efficient system. That's good. Like if your camera, instead of consuming 100 watt hour, consumes like a 60 watt hour, that's awesome. So industry will always give you like a smaller and smaller equipment, simply because they are not focused on that. Like you can buy right now industrial high speed camera that works on USB 3.0 and gives you around 500 frames per second. For industry, that's more than good enough. So it's like if you want to do something like that, it's more than good enough. So Phantoms are like a bit of a niche kind of equipment, and Chronos is like a guy's passion. Is like, dude, I want to buy high-speed camera. He checked the price of high-speed camera. He's like, dude, I'm out. I'm gonna build my own, and he built it. Like he literally is the most amazing thing I ever heard. It's like, yeah, I have an issue. I'm gonna solve it. It's like simple. I have an issue, I'm going to solve it. Started the camera, build the prototypes, again prototype. Then he had a final form, then he started a Kickstarter, became successful at Kickstarter, successfully delivered the camera and gave warranty on those cameras. So he was like actually providing warranty on the equipment, and is now a properly successful company. It's a small company, as like I think around 30 employees or something like that, but they are successful. And because the cameras are tangibly 3 to 4 times cheaper than any other alternatives, people are just buying two more cameras. It's like, oh, and you can even sync them and get 3D visions and all that. So I can ask a rocket engineer, what would you rather have, one high-speed camera or multiple medium-speed camera? They're like, multiple medium-speed camera. So Chronos is for starters, Phantoms is for like cinema, if you want to like, and many people rent these things out also, so look out for those. And for industrial use, if you really want to do that, there are equipment specifically built for that, and they will specify this can remain 24/7 on. Sensors are generally a bit more thermal resistant, so they do not overheat. So these are your options basically, and be mindful. Like it's painful that you have to spend so much money, but again, it's not a competitor. Like right now, solely because of Chronos, there are other options which have like bit bit more pocket friendly cost, but that's about it. Like you cannot expect Phantom on low price. It's not like Kfinity is gonna come and like give you an awesome high-speed camera. That's not gonna happen. So this was my presentation on high-speed camera. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.